Satch, we strive to provide a product that is guaranteed to work as expected and as specified. Quality product, we feel, begins with a well-thought-out design and finishes with thorough testing. Keeping that in mind, we've undertaken a very serious testing procedure. We've integrated this with our design cycle as well, made our code modular so it can be tested in smaller parts and then in bigger parts, and then as a whole to make sure that everything works together just like we hope it will and believe it will. Each module of code was individually tested by the author of the code, and then we will undertake a system integration test with the code on an emulator, which we borrowed from Professor Peralt. In addition to that, we will use the emulator as the heart of our prototype. We have, as Steve mentioned, received all the parts we need. We're in the process of putting together a wire-wrapped prototype, which we will use along with a test bed that we've developed especially for this project. The incoming data does not come every 10 microseconds or every 5 microseconds. It actually comes in byte pairs. Each byte in the pair is a microsecond apart, and then the next pair is not until about 20 microseconds later. Keeping this in mind, developing a test data pattern was not as easy as it might seem. We actually had to generate a waveform that represented the rate at which the data would come in. At first we were going to go with the aggregate data rate, but then rather than that we decided to go with the actual data timing that we will receive from the microcontroller group aboard the Spectre rocket. In order to achieve the correct test data spacing, we are using a state machine that will clock 12-bit counter. The high nibble of the 12-bit counter will represent the flash number that the data is intended to go to. The low 8 bits are the actual data. Using a counter was perfect for our purposes because it gives us an easy way of looking at the output stream and ensuring that it is what was coming into the machine. After all, the counter would just increment every time. Each 10-bit word coming out would be the previous 10-bit word plus 1 or a control bit. Right here we have the state machine that, well, this actually generates an interim. Right here is the state machine that puts out two signals, a clock that clocks this 12-bit counter, and that's high from interms 0 and 3, representing time 0 microseconds and time 2 microseconds. We also have a reset line going back to the 8-bit counter that feeds the state machine, and that goes high at midterm 20, which represents 20 microseconds, at which point the entire cycle repeats, generating byte pairs. Clock at 0 and 3 microseconds will clock this 12-bit counter that will then generate 12-bit data, first at 0 microseconds, then again at 3 microseconds, and then again at 20 microseconds, which is actually back to 0 because it gets reset by the earlier system. The output text, we will feed the output of our SPI buffer into a logic analyzer, which we again borrowed from Professor Peralt. And the logic analyzer hooks up to our PC, which allows us to save the output bit stream as a text file. The output text file is then translated into a binary stream, which represents exactly what is getting sent to the transmitter. Unfortunately, we are not able to obtain a NASA receiver to actually test the transmitter part of it, but we hope that NASA will have tested that thoroughly. NASA also has us sending 16 analog channels at various sampling rates, and in order to emulate these channels coming into our system, we will use a resistor ladder and take feeds off that in between each resistor, in between each pair of resistors to represent 16 different analog channels, all related to each other, which again makes it very easy to look at the output and say this is correct or this is not correct. That's about it for testing, and just to wrap up, here's our system diagram again. Again, our primary goal in this endeavor was to be transparent to everyone. Our part of the project was added on later, and so we wanted to make sure that all the design work that had been done was not wasted. We hooked it up so that the controller group wouldn't even know we exist. The only group that actually really has anything to input into our system is the power group, but they hadn't worked on anything, any part of their design yet. We do need power, we can't do without it. Other than that, that's it. Thank you.